Welcome back, Retronauts. So we have unfinished business to look at in this video. And we are here today because in my last video, I installed my dream graphics card from 33 years ago. I explained in great depth why I wanted to have that card. So if you want to find out about that, please go back and watch that video. I'll put a link to that above so you can do that. So the theme of that video was, will it scratch a 33-year itch? It was something I really wanted back in the day, and it came up on eBay recently, and I thought I would go ahead and get the card and put it in my machine and finally have the machine that I wanted from all those years ago. Yeah, it's a pretty long time to wait to get an upgrade for a machine. Now, obviously, this computer is not necessarily relevant today. I didn't buy the card to upgrade the machine to make it useful for modern work. It's a retro machine, and I appreciate that. And it's to actually give it 24-bit capability, which back then was something that was very desirable. We had used computers from, I say we, people who were around at that time. We had used computers through the 70s and 80s, which were 8-bit and then 16-bit, where you tended to have, let's say, on the Commodore 64, I think it was 16 colors. Then on the Amiga, you had, say, 32 colors, 64. There were special modes which allowed you to do a thing called ham. Nothing to do with pork or pigs or anything like that. It stood for hold and modify, and then it allowed you to have a sort of pseudo true color display. But it wasn't real time. And what happened was in the 1990s, we started to get cards coming out. They were called RTG cards, and they started to offer 24-bit color and 16-bit color for the Amiga, and also you had the same thing going on in the PC market. Now, these cards were called RTG. RTG stood for retargetable graphics, and it basically meant you could take the existing native display of the Amiga and supplant it with new modes, higher resolution modes, which didn't flicker. That was one of the big features as well. They didn't have any sort of flickering. But for that, you had to have a VGA monitor, and we'll be discussing why that is later on in this video. RTG allowed third-party vendors to make modern graphics cards for the Amiga, and this leveraged modern graphics chips that were being developed for the PC and other platforms such as the Mac. Now, for the most part, it went really smoothly, and we installed the card and its drivers, and it basically worked. Except there was one aspect of the card that did not work, and this was its pass-through feature. Or rather, I did not actually have a suitable setup to make use of that feature. So in this video, we are going to attempt to get that pass-through working. So let's take a look at that next. Now, what do I mean by pass-through? Well, the card itself actually outputs video via a VGA connector, standard VGA connector, which would have been defined back in the 1980s. And it uses a 31 kilohertz VGA signal, a standard for the PC. This is expected to be plugged into a standard VGA monitor. There are other monitors that it can get plugged into. We'll talk about that a bit later. But for now, let's keep it simple. VGA connector, VGA cable, VGA monitor. Fantastic. The problem is that the Amiga's own original display modes, they use a slower standard, a standard that was developed for TV, which runs at 15 kilohertz. So basically half the speed of VGA. Now, we'll go into why a little bit later. Hopefully you'll find that interesting. I think it's good to find out about the technicalities of why we're doing something, not just how to do it. So I'm going to explain that, and hopefully, like I said, you enjoy that. If you don't want to watch that, then please skip ahead in the video and get to the parts where we try and solve this problem. So the pass-through is where you take the original 15 kilohertz signal of the Amiga, and then you pipe it through the graphics card so it comes out of its own VGA port. Now, the problem is there are some technical points you need to achieve for that to really make sense, because a VGA monitor cannot display 15 kilohertz signals, the signals which come out of an Amiga by default. It's a pain. There's a good reason why this came about, and it's not because there was anything really wrong with the design of the Amiga originally, but there were certain decisions that were made for a good reason, and because of that, it pinned its colors to the mast in terms of it being a native TV, basically, platform, and because of that, we have these issues today. Or rather, we had these issues back in the 1990s when you got one of these cards. So what I'm going to try and do in this video, as well as explain the technology behind it, is to go through those steps and actually get this working. Now, I must say, I was very much surprised how successful the previous video was. Up to this point in January, I think it's January the 23rd or 24th, it has already achieved 27,000 views, and that is over twice as successful as my previous successful video. So thank you very much to everybody who watched it and left comments, even if some of them were a little bit snarky. But those comments also provided a lot of tips and feedback, and I crawled over those comments, and from them I have put together a plan to get the pass-through working in today's video. So what options do we have? So number one, we can do what I did in that video, and we can basically use two monitors, or with modern technology, we can use a single monitor with multiple inputs, and then we can switch between those inputs. So what I want to do now is show you how that works, and we're going to use the machine here. So I'm just going to turn it on, and we'll just let it boot up. Now I must explain something, which is that the A2000 that you can see here already has a graphics card in it, a kind of graphics card. And what it does is it takes the native signals from my Amiga, and it actually doubles the speed of those so that it can actually be displayed on a HDMI monitor. As far as I understand, it needs to basically adhere to the VGA standard. It also then outputs those signals through the back of the card using a HDMI port. So what you're actually seeing here is, the monitor that I mentioned earlier displaying the signal from this machine via HDMI. This is a common upgrade that a lot of people have done for an A2000 because it means obviously that you can use the machine with a modern monitor like this one here. Now, if I want to change to one of the Piccolo modes, I have to go to here, Preferences. So let me just do this quickly. And I'm going to go to Screen Mode, and I'm going to go down here to one of the Piccolo modes. So I'm going to go for 800, 600, 16-bit. And on the Amiga, the way you set up your display mode is kind of similar to a PC, where you generally test it first to make sure that it's working. And then if it is working, you then go ahead and use it and save it. Now, you've got to be careful. Obviously, you don't want to sort of save a display mode that the machine can't handle. And so here we have test, then we have use, and then we have save. So save is basically use and save, and use is just use, but without save. So if I restart the machine and I only use a display mode, when I restart the machine, it will go back to the current mode. The current mode is a native Amiga mode. It's actually a high resolution mode. And because of this HDMI card, it's actually doing flicker fixing, so you don't get a flicker. But if I move my mouse cursor, it does actually show some fracturing of the cursor, which shows that it is actually in an interlace mode. And I'll explain what that means a little bit later. So let's use this mode. And what you should find is that this monitor will go blank, because now what's going to happen is the machine's going to switch over to the Piccolo card, which is in here. And the VGA signal is coming out of the back and is plugged in here. That's actually VGA there. And right now, the native modes on the Amiga are not going to display anything. So to get around this, what I can do is I can click on here, go to the menu, there we are, and then I'm going to go down to input source, select that, and we're going to go up to VGA, and we're going to select that. And hopefully what will happen in a second is it will pick up the VGA signal, and there we are. So this is now displaying the workbench in 16-bit color, which means all these icons look a lot better. It's stretched, but that's something that we can deal with a little bit later in this video. And to be honest, even stretched is actually really nice. The icons are actually close to 1-to-1 aspect ratio. In other words, these discs look like basically circles, so it's not bad, to be fair. Now, the problem with this is, now if I want to go back to using HDMI, in other words, one of the native Amiga modes, and you do need to do this because if I wanted to play a game like Flashback, the machine would then ideally display using one of the native modes. You can't play the game in one of the Piccolo modes. Now, when you do that, it's going to come out of the HDMI and you're not going to see anything because you're now in the VGA mode. And I would imagine that the monitor would also go blank at that point. So if I turn the machine off and I turn the machine back on, it's now going to boot back up using the HDMI mode. As I said, I didn't save that setting, so we're going to go back to using the monitor. Now, this particular monitor, which I picked up literally today, it doesn't switch between inputs very freely. It doesn't tend to auto-detect and then switch. I only discovered this earlier, so you tend to have to manually tell it to switch to a different display mode. So I'm going to have to go back into that menu. So let's do that now. I'm going to go down to HDMI and select that, and it's going to go back to HDMI. There we are. So, as you can see, it's not exactly the easiest workflow, is it? So I think we're not going to use that method. It's a real pain. We could actually make it a bit better by using two monitors. So we could, if we wanted to have the VGA come out and go into this monitor, and we could have the HDMI come out and go into this monitor. And then when we switch back and forth between the two different modes, this monitor would go blank when it's in HDMI mode, and this monitor would go blank when it's in VGA mode. But the reality is you're not really getting that much use really of the two monitors, and it's going to use up a lot of desk space. As you can see, these are 24-inch monitors, pretty big. And ideally, we'd want to have one monitor that can handle, both situations. So what we can do is, and this was something that I kind of was trying to do in the last video, but I didn't have the magic part of the puzzle, which is that we can take the signal from the Amiga, not this HDMI signal, but the actual native 23-pin video signal coming out of the back of the Amiga. We can pipe that using a pass-through cable into the graphics card, and then that signal can then come out of the graphics card and into the VGA monitor, and then drive it. Now, the only way that this can work is that it can't actually be a standard VGA monitor. It has to be what's called a multisync monitor, which can actually accept 15 kilohertz display, because the signal coming out of the Amiga natively is 15 kilohertz. So if we don't have that special multisync monitor, it's not going to work. Now, the reason why I have these two monitors here is because I actually bought them specifically for this video, and it was from the comments in the last video that I actually found out about this particular model of Dell monitor. I am assured by one of the channel's viewers that these monitors actually work in 15 kilohertz. And VGA. Well, we've seen it working in VGA. I haven't yet tested it in 15 kilohertz. So what we're going to do in this video is that we are going to go through the process of trying to get the pass-through cable made that will work. And then we're going to attempt to get a 15 kilohertz signal to go through the Piccolo card and come out into this monitor. And hopefully, if it does support 15 kilohertz, as the viewer said, it should work. Which is pretty interesting, because I thought you had to have a special card called a flicker fixer to really deal with the situation. We'll talk about that next. But apparently you can get hold of a multi-sync monitor. And I kind of remembered this from back in the day, but it was 33 years ago, so I had forgotten about multi-sync monitors. So you could actually buy a CRT monitor. There are multi-sync CRT monitors, those were the original ones. They are generally quite hard to find. Now, the next option. We can use a special board, which is called a flicker fixer. And what that does is it takes the signal from the Amiga and it doubles it to 31 kilohertz. And then it will then basically do the same thing again. We put the pass through from that card rather than the native Amiga signal. So this is actually one of these cards here. And I've bought this specifically for this video. It's called a Multifix. It's Multifix OCS, ECS, AGA. It basically works with all of the different Amigas which have a video slot. In other words, a big box Amiga. And on the back of it has a VGA output, and you should be able to put this into this Amiga 2000, plug it into a VGA monitor, and have the native 15 kilohertz modes of the Amiga display on a VGA monitor, because they've been basically scan doubled to be 31 kilohertz. So this is kind of, I suppose, the preferred method that a lot of people use these days, because multi-sync monitors are actually quite hard to come across. I didn't know that there was a Dell monitor that's apparently multi-sync, and we'll see if that pans out later in this video. So yeah, we have two main options. Option one, multiple monitors, or a single monitor with multiple inputs for me isn't a good option. So we are going to look at option one, which is using this multi-sync monitor with a custom pass-through cable, and then hopefully the monitor will handle the 15 kilohertz signal and everything will be great. And then the next thing we're going to do after that is we're going to look at using the flicker fixer card that I just showed you, and we'll be trying this out because even if option two fails, in other words, using the multi-sync monitor, option three should work no matter what. And there are a lot of VGA monitors out there, so for many people it will be the preferred option. So we'll have a look at that as well. So before we carry on and do that, we're going to take a look now at why the Amiga displayed video at 15 kilohertz. It may seem a little odd if you think about VGA and how much of a standard it became, but you've got to understand that when the Amiga came out, VGA didn't exist yet, and the Amiga was designed to fit a certain market. So yeah, let's have a look at that next. In 1979, Jay Miner, the engineer responsible for the graphics chip in the Atari 2600, and then later the Atari 400 and 800 computers, saw the launch of the 16-bit 68000 processor from Motorola and was inspired by it. He saw it as being a groundbreaking piece of technology, and Jay wanted to make a computer using that chip. Jay made the case to Atari management that they should release another, more advanced 16-bit computer based on this technology. But unfortunately, they refused to greenlight this project, and they also did not pay Jay and many other engineers a bonus that they were owed. So Jay decided to leave Atari to work at Zymast, designing custom chips for medical pacemakers. 3 years later, and in 1982, Larry Kaplan, an ex-engineer at Atari, yeah, you can see there's a bit of a theme building here, he was now working at Activision, and he called Jay with an idea. He was now frustrated with working at Activision, and he suggested to Jay that they both leave their respective companies and form a new company to build a new console. Jay would design the hardware, and Larry would lead its game development. Jay thought it was a good idea, but rather than just leave his company outright, he brought in his boss at Zymast, Burt Braddock, because he knew that Burt knew money people and had obviously business experience. So Burt went on and found a suitable CEO for the new company, Dave Morse, who was then an executive at Tonka Toys in marketing. And in an odd turn, Kaplan left Hi-Toro before things actually got moving there. It appears that Kaplan was not an easy person to please. This left just Jay and Dave Morse and the investors to work out between them what their new product should actually be. Jay wanted a pure 16-bit consumer computer, but the investors insisted it be capable of being sold in a console format. So Jay agreed and made start on the design, and also started hiring an engineering team to make his vision a reality. Originally, this new chipset was called the Lorraine Project, but in 1983, Hi-Toro was renamed to Amiga Corporation, and the technology was renamed to Amiga. This was because the investors were not happy with the name, they felt it needed something friendlier, and they arrived at the name Amiga, which fit their bill. And so it became a core part of the new display chips technology that this machine had to work on television technology, and TVs have a 15 kilohertz data bandwidth. Now, this was a major feature of the machine which made it highly suitable for use in television production, as it worked natively using television standards. However, this also proved to be a problem later, as Commodore, when they bought the project, ditched the idea of a console and instead positioned the Amiga squarely as a 16-bit graphical workstation. As the display chip fleshed out, the Amiga could display a 320 x 200 pixel image on an NTSC television. Reducing its resolution from the theoretical maximum that you could actually display on a TV meant that it did not have to use interlacing. Interlacing updates the screen every 60th of a second, but when it does so, it only updates half of the displayed lines at any one time. First the odd lines are updated, and then the even lines, and in this way, the TV stays within the bandwidth limitations of the broadcasting system. Interlacing on a broadcast TV image does not noticeably flicker, but when used for a higher contrast computer image, for example, white text on a black background, the flicker was very noticeable. This was not a serious problem on launch in 1985 because a non-flickering 320 by 200 pixel image was actually quite adequate for that period, though to be fair, it wasn't ideal. Remember though that the Amiga design had to work on a TV because it was destined to be released as a console, although that actually didn't happen in the end. So Jay had produced a technology that did just that. But when the Amiga was launched, it was sold as a high-end graphics workstation, and at this point, only supporting higher resolutions using interlacing was not going to work for many users focused on productivity. So, I've mentioned NTSC and PAL, interlace and so on and so forth. Let's take a deeper look at those terms and the technology behind them. NTSC stands for National Television Systems Committee, whilst PAL means Phase Alternate Line. Both are CRT, TV colour broadcast standards. The NTSC standard was defined in 1953 in the USA, whilst PAL was patented in 1962 in West Germany. Because of broadcast bandwidth constraints of the 1950s and 60s, analog television standards were first defined with these limitations in mind. Signals were broadcast via radio at 7 or 8 MHz, and the video, audio and synchronization data all had to fit in this analog stream. This was also the era of vacuum tube technology, so compromises had to be made in a number of areas to get this technology to all work. This being said, the TV broadcast system was certainly a standout technical achievement of its time. NTSC television in North America refreshed the display at 60 Hz to synchronize it with the AC power grid frequency there. This avoided interference patterns appearing in the resulting image. This gives an effective maximum resolution of 720 pixels horizontally, but this is something of a fluid concept because lower resolutions are also possible. It's important to understand that with CRTs, there are no hard defined pixels. It's a scanning electron beam that creates its resolution, and this is an analog system. Therefore, you can create, if you wish, pretty much an arbitrary number of pixels across the scan line, but as I said, there is basically a maximum of 720 pixels. These NTSC numbers were not pulled out of thin air, they were arrived at to make the technology work with the given broadcast bandwidth and CR tube technology of that era. The PAL standard came a little later and was designed in West Germany to work with European 50 Hz AC power grid, obviously slightly slower than the American 60 Hz. It was patented in 1962, but it actually took until 1967 before the system went live, both in West Germany and in the United Kingdom. The lower 50 Hz frequency meant that only 25 frames per second could be delivered. But this had no real drawbacks for TV broadcast, as early experiments in cinema showed that 24 frames per second or above were perceived as constant motion. And remember that again, you had a partial update every 50th of a second, so the eye perceives motion as being more like 50 frames per second. In PAL TVs, the horizontal frequency is 15,625 Hz, so you can see that it is marginally lower than NTSC, though it doesn't really have any deleterious effect. Again, on PAL, you can display 720 pixels or lower horizontally. So, to summarize, PAL offers a lower frame rate, but better vertical resolution and overall image quality over NTSC. So we've talked at some length about the fact that the Amiga uses the 15 kHz standard that TVs of that era used. So the question arises, why do RTG cards like the Piccolo SD64 in this machine use the VGA standard? So the problem with TVs is that if you want to display non-flickering modes, you must go lower than the native vertical frequency to display all the scan lines at once, which we call progressive mode today. An NTSC TV can display 525 lines vertically, but to avoid flicker, this must be dropped to 200 lines, and that's it. To get around this, VGA monitors doubled their refresh rate to 31 kHz. This meant that VGA could display images with 480 vertical lines with no flicker, and this was very useful for computer productivity and was a must for the IBM PC, a system focused solely on business users. When RTG cards were being specified for the Amiga, most computing users wanted 31 kHz modes, just like VGA, so flicker-free modes could be supported on the Amiga. The VGA standard, at least in terms of refresh and also cables, was adopted, so cheap VGA monitors could be used. So why do we need pass-through? The problem with VGA is many users also needed to keep their 15 kHz modes working, as these were required for TV production, which the Amiga had moved into as something of a power player, at least in lower-end TV production. On top of this, if you wanted to play games, then you also needed to use 15 kHz modes, as all games were written using the native Amiga TV modes to display on televisions, which the vast majority of Amiga users still used. So, we need to have VGA-like modes with no flicker, while also having 15 kHz modes for TV output. Tricky. So we need now one of three approaches if we want to eat our cake and still have it. Number one, we connect our RTG card to a VGA monitor and our Amiga's native output to a TV, or as we saw earlier, we connect them both to a monitor that can switch between these two different standards. The second approach is that we double the refresh rate of our native modes to 31 kHz so they can natively display on a VGA monitor. Or we use a monitor which can display both 15 kilohertz and 31 kilohertz signals. As I said earlier, this is called a multi-sync monitor, and we actually have one of these behind us now. So pass-through then is simply a way to pipe the Amiga's native display through an RTG card and out to a single VGA or optionally a multi-sync monitor. In theory, if your monitor supports 15 kilohertz, you can pass through your 15 kilohertz modes to it and it should work. Alternatively, with a flicker fixer card in place, your native modes should be at 31 kilohertz and should work with a simpler and cheaper VGA monitor. So let's crack on and try out method 3, which is passing through the native 15 kilohertz modes to a multisync monitor, just like the one that I should have behind me, hopefully, fingers crossed. And for that, we need a pass-through cable. So let's get on with making that. But before we do that, let's have a quick word from our sponsor, PCBWay. PCBWay, where you can make your tech dreams a reality. And now in PCBWay's Project Share, you can upload your projects and share them with the community. And if you do use any of these projects, a percentage of the money that you pay will actually go to the author. So you can share your projects and you can also benefit the projects that others have shared on PCBWay. So if you do have any projects, why not upload them to PCBWay and get them out to the community? And of course, why don't you browse the Project Share and see if there's something there that's interesting for you? Because whether it's PCB prototyping, PCB assembly, 3D printing, or even CNC machining, PCBWay is the way. Starting with an instant quote for your PCB projects, PCBWay will leap into action, building your PCB, assembling it for you if you wish, and once it's passed their quality tests, it'll be winging its way to you in a flash. PCBWay, PCB prototyping the easy way. Okay, so this is the cable that I put together. And believe me, there was a lot of frustration actually getting this into a sort of shape that I was happy with it. This will tell you a story if I show you this as well. This was the original, this is the 9-pin connector. Unfortunately, one of the things that's a little bit frustrating about the Piccolo card is that rather than using a VGA connector to do the pass-through and using, for instance, standard VGA connections, which would then mean all you have to do is just get a VGA cable and plug it from, let's say, a flicker fixer, which would have a VGA out, into the Piccolo card, which would have a VGA in, and then the VGA out would come out of the Piccolo card and you plug it into a VGA monitor. It would all be VGA pure, as it were. They decided to use a 9-pin connector. I'm not sure why they did that, but it is what it is. I've got these the type of connectors that you assemble yourself. Now this one is obviously, well, I've got this case, but this is now dead. And the reason why I aborted this is because it went through so many different revisions that the actual connector got really a bit melted. It's very difficult to solder these things and not avoid getting some of the heat into the plastic. And if you do it too many times, the plastic itself starts to melt, and then these little pins where you actually have to solder on, they start to wander and they can get close to each other, and obviously then they can make contact, and then it's not a very useful connector anymore. So at some point, actually quite close to it being finished, I decided to chop off the wire and make a fresh start. Yeah, let me just show you on screen exactly what the plan was originally, and then I'll explain to you how it changed, and that's why we've ended up with this connector. So in trying to make this cable, making this at all was only really possible because of Amiga Wiki. So thank you to them to have this particular page on display. I'm assuming that it's been lifted from the manual. Right now, the manual is not available anywhere on the internet, unfortunately. I had a kind gentleman from Australia offer me to translate the Picasso manual, but of course, that's a different card. So if anybody out there has the manual, either for the original Piccolo or the Piccolo SD64, it'd be really fantastic if we can arrange to get this manual digitized in some way so we can have it on the internet for posterity, because there are going to be other people out there with this card. So anyway, let's have a look at the diagram that we have here. On the left-hand side is the legendary 9-pin socket that I was talking about. Rather than using, as I said, a VGA, they've used this. So anyway, it is what it is. So what's really nice is this, can you see up there, it says the pin assignment is as follows. When looking at the card from above, pin 1 is top right and pin 9 or pin 15 is in the bottom left corner. Very useful because it does give you a very strong indication of the direction that you're looking at the connector. In this case, we're looking at it from the front. Sometimes when you see diagrams, they are from the rear. And it can be either way, and then it can be tricky then to work out which way you should actually wire up the plug. So if we're looking towards the connector on the back of the Piccolo, you can see that the top right pin 1 is red, the red signal, 2 is green, 3 is blue, 4 is horizontal synchronization, but it also says joint sync, H and V, so I'm assuming if you have a combined signal, you can connect that there instead. So yeah, interesting that. But then on pin 5, we have vertical synchronization. So I think for my initial attempt, I'm going to go for separate horizontal sync and vertical sync, because that would probably be, I would assume, the best quality. Then we have analog mask for red. I didn't quite understand what that meant, but I looked it up, and it means the ground for the red signal, which is interesting. There was a big debate on the previous video about how much ground was needed, if you needed separate ground for the red, green and blue. But what I'm trying to do in my initial attempt at wiring this together is I'm probably going to try and do as many as I can, given the available wires. The cable that I have only has 8 cores, not 9. So I can't connect all 9 pins up. So I have to therefore, make a choice about which ground I'm going to go for. So yeah, anyway, we've got 6 is ground for red, 7 ground for green, 8 ground for blue. And then you can see for 9, it has analog ground for synchronization signals. And then it has ID 0, so I'm not sure what that's about. That's pin 11 on VGA. You can see the 15-pin VGA socket, it's pin 11. But on the 9-pin socket, it's also pin 9. So I don't quite understand how pin 9 can be both. Interesting. So anyway, let's have a look at the original plan, what I was actually going to do with this. There is a little bit of an explanation I should give about this diagram, and that is I've tried to color code the text the same color as the wires where it makes sense. But in one case, when it's white, that doesn't make sense, because if I do that, obviously on a white background, you're not going to be able to see the text or the input. So what I've done in that case is I've compromised and I've gone for gray to represent white, the white cable. These are actually the colors that I actually have inside my cable. So it's color coded for the particular cable that I have. So I actually found this diagram online, and I've used that as the basis of this wiring. I also cross-checked this with Wikipedia. Wikipedia actually has a page on this as well, but interestingly, they don't have a diagram there. They only have a list of the pins and what they all do, which is obviously suboptimal because it's debatable how many pins are on each row, etc., etc. So anyway, managed to find this out there on the internet. I'm not quite sure who produced this, but obviously I'm giving credit to them, whoever they are. So you can see top left, we've got X clock and then XCL Ken. Sure what that is. Then we got analog red, so that's a signal we need. Analog green and blue, so we will have to use those. Then we've got digital intensity, don't need that. Digital red, digital green and blue, we don't need those. Then we have combined sync, I'm not going to use that. We're going to use horizontal sync, as I said, hopefully, and then vertical sync. And then on the bottom row, bottom left, we've got ground return. It says do not ground that. Anyway, we're not going to use that one. Pixel SW, so for a gen lock, we're not going to use that. Then we've got C1, clock out, we don't need that. Then we've got the grounds. So we saw that in our diagram, we do need ground. So we've got ground for red, ground for green, and ground for blue. So we're going to try and connect those up in some way. Then we've got ground syncs. So that looks like it's a combined ground for all of the syncs. And then we've got ground video. Interestingly, the bottom 3 right pins, it does say that this is variable on the 3rd pin from the right, have quite high voltages going through them. So minus 12 there, 12 volts, and then 5 volts. So I would assume that if you put that through a VGA cable, that would be bad for the other side of the cable, whatever's receiving that. So I'm noting that here. And if we go back to our diagram, you'll see bottom left there, I've noted there, pin 21, minus 12, minus 5, 22 and 23. And that's just a reminder to myself to completely avoid those, make sure they're not connected up. So now if we look at this diagram, you can see that I've left in only the pins that I want to connect up. So pin 3, we're looking at the D-sub-23 here on the left. This is the Amiga's video out. We've got pin 3, which is red, 4, which is green, 5, which is blue. We've got 11, which is horizontal sync, and 12, which is vertical sync. That's the white wire. As I said, that's encoded here as being gray. And then on the bottom row, we've got on the left, on 16, we've got red ground. I've tied together 17 and 18, so that's why we're showing yellow for both of those, and that's why I put a little disc on the left-hand side to show that that particular wire is actually going to connect up those two. And then we've got 19, which is sync ground. because if we've got these sync signals being sent, I suppose it makes sense that we kind of ground them as well if we can. And apparently that's a combined ground, so I'm going to try and do that. So on the right-hand side, you can see then where they wire up. This is based on the diagram from Amiga Wiki. So top right, we've got red, green, and blue. They're obviously the most important signals. Then we've got horizontal sync, which is black, and then 5 to the left of it, which is white. And then on the bottom row, kind of going in the opposite direction actually to what we saw on the Amiga side, we have on the right-hand side red ground, then the green and the blue grounds tied together, and then 19 we have sync ground. So let me tell you what happened. This was actually done in the last video when I was trying to get this cable working, until I realized that this was never going to work because I didn't have a multi-sync monitor at the time. So there was no chance that this was going to work. I plugged this into the video, and then I plugged it into the back of the Piccolo card. What I found, which was really interesting, was that I believe it was pin 12. Yeah, the white pin here, or where I should say the white cable was connected. For some reason, whenever I had that connected, the Amiga wouldn't boot. And I tried swapping it around and doing different things with it. And this is the reason why that 9-pin connector that I showed you just now got so burnt up, because I had to, connect it to at the end of the day, it was never going to work because I didn't have a multi-sync monitor. However, I did learn something, which is that pin 12, there's something about it that causes the Amiga not to boot when it's connected to anything. It would turn on, but the hard drive wouldn't boot, nothing would happen. And then I would disconnect that pin 12. And as soon as I did that, the Amiga would boot. So I did a little bit of research and fiddle around. And what I found is this is actually what we're going to go with. I've changed a few things. Most notably, if you look at pin 12 and pin 11 on the Amiga side, the D-sub-23, you can see I'm not connecting those anymore. And I've actually gone for the pin to the left of them, number 10, which is composite sync. So composite sync actually has horizontal and vertical sync, both in the same signal. And if you remember, if we looked at the diagram from Amiga Wiki, pin 4 was shown as being combined sync. So that seemed to be, because look, the interesting thing is pin 12 vertical sync just would cause the machine not to boot. And you have to have vertical sync, as far as I understand it, in a video signal in an old CRT monitor. So you can't really not leave that out. So I was scrabbling around to think, what do? I haven't got vertical sync. It's never going to work. But then I found composite sync, and composite sync contains horizontal and vertical. So I decided not to bother connecting up horizontal, as it should be contained within there. And as long as it works, we should be good. So you can see that now pin 10, the white cable is now going from there to pin 4 on the D-sub-9. And that is the combined sync on that side. Now, if we go down to the bottom row on the D-sub-23, you can see I've now connected up red ground, green ground, using yellow now, and black, because black isn't needed anymore. And I found that when I was trying to connect that up on the old connector, it became very difficult. The length of the cable was a bit of a nightmare, and I'd have to desolder everything again and start again. And I just thought at the end of the day, it had reached the point where the connector itself was becoming a bit mangled, and it was good to just chop it off and start fresh. So that's what I did. So I've wired it up exactly the way that you see here. As I said, black is now blue ground, and then 19 is the ground for both syncs. So yeah, this is what I have wired up. So let's take it over to the desk, and we'll connect it up, and we'll see what we get. So what I've done is I brought you in pretty close, and I've turned off the lights. Mostly I've left on the house lights. And what I want to do is I just want to show you what the picture looks like without the cable plugged in. So let's just turn it on. I was thinking about doing a screen grab of this, a screen capture of the live video, which would obviously give you the best picture. But the problem is I only have one capture device, and I'd actually have to capture VGA and HDMI, because obviously when we switch to the Piccolo, it'll be coming out of the VGA port on the Amiga, and it's just too many hoops to jump through, So hopefully you can see the quality of that image there. It's actually mint right now. This is coming out of the HDMI using the RGB to HDMI card here, which actually does have a flicker fixer built in, and this is actually an interlace mode, which is why it's actually relatively high resolution. But yeah, this is actually flicker fixed, and hopefully by the end of this video, we won't have to use this mode anymore. We can just use the native Piccolo modes. And then obviously with the pass-through, we'll switch over. So with that done, let me turn off the machine. Let's plug this in. So I'm going to plug the DB23 into the Amiga's video out on the left-hand side of the back. That's right next to the RGB to HDMI. And then I'm going to plug this into the 9-pin connector, the pass-through connector on the card, on the Piccolo. So let's turn on the machine again and see what we see. Actually, when you're seeing this 1920 1200, that's actually the RGB to HDMI booting up, because it's a Raspberry Pi, so it just tells you that it's booting. So as you can see, the picture's the same, no differences whatsoever. So what I'm going to do now is I'm going to switch over to a Piccolo mode, and we'll see if that works. I think it should. So here, preferences, and then screen mode. And let's go down here to 800, 600, 16-bit. We'll use that. We're not going to save it for now. I just always want to go back to using HDMI for now, once, until we're certain we have a good solution. Now I'm going to have to manually switch the monitor over. And as you can see, the Piccolo card is working and we're in 16-bit color, which is great. So next what we need to do is I'm going to try changing to one of the native Amiga modes, and we'll see if we actually get a picture. Let's try that. So screen mode. Let's go for low res. And let's test that first. So it's going to do a test. There we go. It's working. So I don't have a keyboard plugged in right now, so we'll just have to wait for that to count down, and it's going to go back into the original mode. And then what we'll do is we'll actually use that mode, and we'll see what it looks like in terms of quality. So let's go to use it. There we are. So it does work. However, hopefully what you can see is, and this is picking up on the camera, there is actually a lot of interference that I'm seeing. And it's like wavy lines that are moving around. And I think the reason for this is because of the quality of the cable that I used to actually make this connector. Don't forget, this is kind of experimental. I haven't done this before. And the cable that I've used is not shielded, so none of the wires inside it have any sort of electrical shielding around it. So I think what's happening is that the red, green and blue signals are actually interfering with each other. And you're getting crosstalk, and that's causing the interference that you can see here. However, a couple of important things. Number one, you can use pass-through from the 15 kilohertz native Amiga signal if you have a monitor which is multisync. And number two, we've actually proven that this monitor is actually multisync. So yeah, it's great that this obviously works. We have an image using the 15 kilohertz coming out, going into the Piccolo card, the pass-through works, and it shows that you can actually do it this way, which is really great. It's a fantastic proof of what people were saying. And this is one of the things I want to do in this video. I want to walk the walk and help you by showing that if you want to do this with your own RTG card, that you can actually do this. I will explain something actually. You must be wondering why I actually have two of these monitors. I'm not being excessively extravagant by buying two of these. This was actually bought first. I bought this and it was not last Saturday, it was the Saturday before. I came back from a trip to Brazil and I was very tired, but I'd actually bought this monitor whilst I was in Brazil. It was on the market on eBay, and I had to go to North London on a train to pick it up because basically driving there would have been really painful because of all the traffic lights. It was actually much faster to get a train. I inspected the monitor when I got there, couldn't see a single mark on it, carried it back to my house in a large bag, a kind of IKEA bag, taking great care to make sure that no damage came to it. Unfortunately, when I plugged it in the following day to test it, it turned out the panel was actually broken, and I was absolutely gutted. It was a lot of work to travel there to go and get this monitor for this video, but yeah, it wasn't going to happen. The only thing I did get out of it, actually there's an arm which this is on, and I really like it. So what I think I'll do is I'm going to take this monitor off this arm, and I'm going to take this other one, which is the same monitor obviously but working, and I'm going to put this monitor on the arm, and I think I'll end up using this arm because I really like the way that it sort of frees up the desk space and you can get the monitor above the Amiga. If, of course, it will fit underneath the shelf, because I have shelves going around the room, so we'll have to see how that goes. This monitor, I picked this up the following weekend, the following Saturday, I think it was. Yeah, that's right, 11 a.m. It does work. it is quite tired. On camera, it does actually look quite pink. To the naked eye here, it actually doesn't. It looks grey. I had to do quite a lot of work fiddling around with the settings to get it to do that. But it's actually quite dim as well. And I think this has been well used, and unfortunately the panel on this is a little bit tired. So that's one thing I would say about these monitors, is that you may find that when you get one, if you want to get one of these, you may find that it's had a bit of a hard life, and it's not in great condition anymore. Having said that, to the naked eye, when you're using it, it's actually pretty good. But I know for a fact that it is actually pretty dim, especially when you compare it to modern monitors. So what I might do is take this one apart, try and find out what the panel is, and see if I can get a replacement panel from China. Maybe they're still available. That's one option. And then the other thing is, if I do find I can get a replacement panel, I may then get one for this and for this as well, and replace both panels and get, hopefully, back to what is pretty much a brand new monitor. The only thing is that this, I think, has 400 candelas, I think it is. And I did see one on AliExpress that was 300, so it wouldn't be as bright as this when it was brand new. But at the same time, if it works, it's better than having a completely broken monitor. And as we've seen, it is actually a multi-sync monitor, which is really cool. So I may pick up more of these in the future. But anyway, for now, it's doing the job and we've got our cable working. So the next step now is I'm going to install this card, the flicker fixer. And I think what we'll do is, once we've got it installed, we will just plug it directly into the monitor using a VGA cable, because don't forget, this is actually VGA out. And we'll just test to see if the card itself works, because obviously there's no point moving on with making a pass-through cable unless the card actually works. If that works, then we'll make a cable. And I have a plan which hopefully will make sure that that particular cable doesn't suffer the same problems as what we currently see here, this interference. What I've done is, I've bought another VGA cable. I do actually own a number of them, and some of them actually have ferrite beads on the end. But this one here does have ferrite beads, and it's purported to be a high quality cable. That may just be marketing, but on the Amazon product page, it did actually show a cutaway of the cable, and inside it showed that the red, green and blue wires actually are shielded. Now this is a VGA cable, so I would imagine it will have all 15 pins connected. I'm not really sure. So that's also interesting. That may allow us to wire up the other cable. But if this works and the flicker fixer works, then I'm not really sure that I need to create another version of the other cable, although I may do it just to see if it makes a difference. So yeah, first of all, we need to make this, but before we do this, let's get the flicker fixer card installed and see if it works. So a bit of explanation before we moved on. This is actually the working monitor. I've taken the broken monitor and taken the base from this, the stand, put those together, and I put them under a desk over there, because until I get round to having a look at that and seeing if it's possible to repair it, yeah, need to get that out of the way. So at least now it's on the arm. Take the screws out of here. I'm just going to turn this on for a second, because now that we're going to move towards using this, which is VGA output, I do need to permanently switch the machine to use VGA ongoing, because obviously once I take out the RGB to HDMI card out of here, we're not going to have HDMI anymore, and we're going to have to switch over inputs. So there we are. There's the machine working, currently using HDMI. So I'm just going to click on here, very quickly change over to here. I'm actually going to use, I was doing some checking, and it looks like this 8-bit mode is actually better because it centers the screen. I was actually losing the menu when I was using 16-bit. So for that, I'm going to have to use Picasso 96 mode to do some tweaks off camera. It's pretty laborious stuff, but yeah, I need to do some work on that. So we're going to save that and just wait for it to change modes. And let's just change the monitor over to using VGA. There we go. That's working, great. So let's turn off the machine. We'll take out the mouse and the adapter, using a USB mouse with an adapter. So let's take off the case. There we are. Put this out of the way. And what I'd like to do is have a look inside before we actually take out the RGB to HDMI, so you get an idea what's actually in the machine right now. So this is the machine as it stands. On the right here in the video slot, we have an RGB to HDMI. That's currently giving us HDMI, as I've been explaining earlier. Here we have a Dick Olga accelerator card. This is actually a 68030 accelerator. That's the 68030 there. And we've got the FPU below it. And then here we've got the Piccolo SD64. One of the viewers in the previous video complained that I had it in the slot, which is used as a PC bridge board. What I've done is I've moved this bar over here and I've moved the card over to the right just to make them happy. So if you were the one who complained, hopefully that's made your day. Right then, so let's get in a little bit closer and let's take out this RGB to HDMI, and then we're going to plug in the flicker fixer. And what I'm going to do is I'm going to take the VGA from here, which is coming from the Piccolo, and I'm going to... Actually, can I do that? Interesting, actually. What I might have to do is to put the machine into a native mode and then save it. It's a bit convoluted, isn't it? Yeah, put it into a native mode, save it, and then obviously plug in this card. So let's do that. Let's turn it on. Oh, actually, we need to plug the mouse back in. There we are. Turn it back on. So yeah, I'm going to have to put the machine into a mode now that it can't actually display because it currently only has this RGB to HDMI. Let's just wait for a second for it to boot up. There we go. Great. Okay, so yeah, I'm going to put it into a standard mode. One of the standard modes that comes with the Amiga. And we're going to go for high-res laced. Yeah, 640 by 512, and it is interlaced. So I'm going to save that. Yes, I do want to use that. And obviously the screen's going to go blank because what's happening now, it's switched back over to the native display of the machine. And obviously there's nothing that's going to work with that because we have the RGB to HDMI. What we need to do now is swap this in, and hopefully that will and then give us a picture. So that's saved. Let's switch it off. I need to unscrew this here to take this out. So I'm having to go behind you. It's a bit awkward, but it's not too bad. Take out the HDMI. Is that free? I think it is, yeah. Yes, it is. Okay. Let's put that screw there for a second. Ah, there's another screw at the bottom. Glad I'm checked. It was feeling a bit firm. It didn't feel like it wanted to come out at all. Which makes sense because there's a screw holding it in place. Okay. Okay, let's try and put some pressure on it now. There we are. Great card. I bought this as soon as I actually bought the machine, so it's been in there since I've had it, got it working the first time round. This machine actually originally had a fault on the logic board because the battery damage had actually eaten away the traces between the CPU and the ROM. So this was actually a bit of a landmark for me in terms of retro computing. The first machine that I actually repaired from being broken and got working again. So let's pop this in here. First time it goes in, so it may be a little bit resistant. Not too bad, actually. Pretty good. Okay, let's put the screw in to hold it in place. There we are. It's a bit snug against the case, I've got to say, at the back. So I'm a little bit worried about that. Anyway, let's plug in the VGA. So I'm going to take the VGA out of the Piccolo and plug it in here. Okay, and then let's try turning it on and see what we get. Okay, fingers crossed. Now it does actually have some switches on the back of it there, so there is the potential that those switches are in the wrong position. So let's see what happens. It's showing some kind of signal, but so far we haven't got any picture. Ah, there we go. Okay. Ah. It's a little bit soft, I would say, compared to HDMI. To be expected, I suppose. And I am seeing a little bit of ghosting on it, I would say, or bars. I would say vertical bars. So It's okay. I'm not wildly impressed, but let's fiddle around with the switches on the back. I'm not quite sure what they do. Okay, well, that's not looking any good. So let's put that back. What about this bottom one? Okay, it just goes a little bit darker. Right, okay, well, the card works. So I guess what we need to do now is actually switch it over to one of the native Piccolo modes. And obviously we're not going to see any picture because we don't have that VGA cable plugged in here. And then what we're going to do is I'm going to go over to the desk over there and we're going to try and get a cable working so that we can then get the pass-through from this card going directly into the Piccolo. So let's change it over. So let's go to Work, Preferences, and Screen Mode. This time we're going to change it back to a native Piccolo mode. So we're going to save that. And obviously when we do this, the screen will go blank. And now I will need to obviously turn this off. Let's just wait a second. There we are. Now we'll put the VGA back in so the Piccolo will work. So let's do this. There we are. Turn it back on, just make sure we've got a picture. Now, while this is booting up, let's discuss our options here. If we find that this card is actually not as good as this card, you know, in terms of the quality of the output, what we could do actually is we could try and get an adapter for this card. And I'm not sure if we've got time to do it in this video, but you can get HDMI to VGA adapters. If we could get an adapter that goes from here to, what would it be? I think it would be a female connector. Then we could actually plug the VGA cable intended for this flicker fixer card and actually have it be the flicker fixer, because this does actually fix flicker. So that is a possibility that we could do that. This is working fine, great. Okay, so we're all set up now to go to the next stage, which is where we make the cable. So I'm obviously going to have to go and do that. I'm not going to do it live on camera, it would take too long. So I'll join you on the other side when I've actually got a cable which seems to be working. Okay, so I worked out in the end. This is the high quality cable, and as you can see here, I've already removed the end. Obviously, that moment when you cut off a nice connector like this always feels pretty bad, but you've got to do it really to get this done. So what I did was I used this as a reference to tell me, you know, where the wires had to go. Red, green, and blue. You'll see something weird going on there. Yeah, I'll explain that in a second. And then on the other side, we have slightly different setup with the wiring. That's because the VGA connector is actually supplying signals which are slightly different from the those available on the Amiga's DB23 port. I actually have the rest of the case here. I've had to cut this back quite far. That's why I have all of this, because otherwise, with this plastic being quite thick, I can't actually fit the case on. If I was to try and do it there, it wouldn't work, so it has to kind of go there. But you can see it's really nicely shielded. There's metal shielding there. There's a ground going around each one of these, which actually shields it as well. So yeah, turned out to be actually pretty good. And the only problem, like I said, was this oddity going on with the red, green, and blue coloring coding. So let's go over to the diagram and I'll show you what that's all about. Okay, so here's the diagram. On the left-hand side, we've obviously got the VGA connector. 3 rows of pins, 15 pins in total, and you can see that I've listed out all of the pinouts, and of everything in grey there is not being used. There are a number of IDs. There's pin 4, which is ID 2, that's not used. Then you've got 11, 12, and 15. They are IDs 0, 1, and 3. And yeah, like I said, they're not used for anything. And then the important ones are pin 1, 2, and 3. Now, this is where it gets a bit confusing because the actual cable itself has 3 thick cables. They're shielded. They are intended, obviously, for the red, green, and blue signals. But oddly, they've actually wired up the blue wire to the green pin and the green wire to the blue pin. So that's not confusing, is it? So yeah, if you look on the right-hand side, you see the D sub 9. You can see there I've got red on pin 1. On pin 2, analog green, which is the blue wire. As I said, it's quite confusing. It does hurt your head. And then on the third pin, which is blue, we've got the green wire. And you can imagine that I just took it at face value. I wired it up and realized later that the blue and green were swapped over. We don't really have separate wires for the actual green, red, and blue ground, but there is actually a ground, and you can see that on the left-hand side, VGA 5 is ground, and I've shown that as being light blue. So again, a little bit confusingly, there are a number of thinner wires, which I toned out with my multimeter, and many of them actually weren't connected to anything really useful. But I did find these are the ones that you can see here, which are useful. And the red, green, and blue thin wires are all actually used. So I've indicated them here by using light blue, light red, which is pink, and light green. And you'll actually see those on the right-hand side where you've got horizontal sync going to pin 4, and then you've got a vertical sync going to pin number 5, and then you've got red ground, which is blue, which is the 5 pin on the VGA. And you can see this on the right-hand side. And then you've got number 9, which is the sync grounds. So what I've done is on the connector, I've actually joined together pins 6, 7, and 8. I'm talking about the right-hand side, so that they all share the same ground. And I gave it a try, and there was success. So let's get back over to the Amiga 2000 and see how it works. Okay, so this is the cable. This is obviously the original end. You know, quite a nice cable actually, quite nice and thick, nicely shielded, really robust feeling. And then at the other end, you've got the connector that I've done. Obviously, it's one of these, put it together yourself connectors. This is the DB9. So yeah, unfortunately, the Piccolo does make use of this DB9 rather than just having a VGA, which would have made it a lot easier to wire up really, just straight through. But anyway, it is what it is. So let's plug it in and give it a go. So this goes into the back of the Flicker Fixer card here. And obviously, when you finish with all of this, you should probably screw this into these so it doesn't fall out. This is quite a heavy cable and it could potentially fall out over time. There we go, that's plugged in. Let's turn that on. We'll just wait a second while it boots up. Should be in a native 16-bit Piccolo mode. Won't take long to boot up. It's pretty fast actually, this machine. There we go. Looking really nice. Obviously, most of the time when I use this machine, once this is all done and dusted, I'm going to be using Workbench in a resolution like this. But then obviously if I want to play games, this is where the Flicker Fixer comes in. And I do want to play games. So let's go to here, Prefs, Screen Mode, and let's go up to the top here. So yeah, this was the mode I was using originally, and this was being flicker fixed effectively by my RGB to HDMI. So let's see what it looks like now. Let's use it. There we go. And there we are. And I must say, it looks pretty good. It's not amazing. You can fiddle around with the picture quite a bit to make it look a lot better. I did get rid of a lot of the jail bars by actually setting it up to be in 1:1 aspect ratio rather than it being stretched. That seemed to be introducing quite a lot of jail bar effect into the image. Obviously, it's lower resolution, and as I said, this is really aimed for video games. But as you can see, the VGA cable does actually work. It's going from the Flicker Fixer into here, and we now have the Piccolo card basically working 100% as it should have done back in the day. Now, there are a couple of other things I want to look at before we finish off. And one of them was an interesting idea that one of the viewers sent in, which is that maybe I didn't really need to buy a Flicker Fixer at all, because in fact, as I've mentioned previously, this card here, although it's not its headline feature, it is actually a Flicker Fixer. It does actually fix flickering. Now, I guess there is probably only one difference really between using this and this, which is that this is using a Raspberry Pi Zero, I think it is, to do the translation. And I have to assume that that would cause possibly a little bit of extra latency compared to this card, where everything is done in hardware on chips. So I guess that's an interesting consideration. So let me get this machine turned off. And what we're going to do is we're going to put this back in, and let's give that idea a go and see how much we get out of it. There we go. That's gone in. Now let's put this adapter in. I have no idea if this is going to work, by the way. I'm just testing this out. It's an interesting idea, but what worries me is that you've introduced another adapter into the entire chain. So who knows what effect that will have on things. But I think it's worth a try. So let's just turn the machine back on. And it should go back to using the 16-bit mode, because we didn't actually save our settings, right? Okay, well, obviously that works. So now for the moment of truth. Let's see what happens. Laced, here we go. Use. Fingers crossed. Yeah, oh, yeah. Not bad. Tell you what, that's actually pretty good. It's a little bit blurry, I would say, compared to the native flicker fixer. And I'm not really sure why that is, but it's not offensive. You know what? They've got a really good point. That is actually reasonably good. What about a different resolution? What about if we try a mode that's not necessarily higher resolution like this? Let's try changing to something very low resolution. Low res. Okay, yeah, let's try that. It's great. That's really, really clean, actually. So yeah, that's interesting. It does look like we have an interesting contender. I would say that looks really nice. Let's try, the problem when you're at this resolution, of course, is that you can't see the preference panel. Can you see it? Yeah, you can, but it's pretty hard to view, isn't it? Okay, let's go back to high-res laced. Let's use that. Yeah. That's actually more usable. There we are. Like I said, you know, it does have slightly softer look to it. The pixels are slightly blurred, but that isn't such a bad thing, you know, because, you know, if you're thinking about video games, they were designed really to work on televisions, and televisions are inherently more blurry than high quality monitors. And especially, I mean, if you compare them to modern monitors, they're really, really soft. But I actually sat next to Dan Malone when he was working on the Chaos engine, and he used to spend hours, funnily enough, with a joystick, adding a pixel, removing a pixel. And I used to observe him doing that, and I found it kind of fascinating how much effort he put into, you know, adding those pixels. He used to blur his vision as well, and that's a technique that I've used when I've done art in the past. He was just looking at the way that the pixel works, especially when it's blurry, because that's actually what the end viewer generally sees when they play a game like, say, for instance, the Chaos engine on a television. So let's just try the Chaos engine and see what that looks like. Hopefully it should work. I mean, so far it's been okay. And like I said, the only downside really, I guess, is that you may have more latency. So if you're playing video games, you may find that the latency of the controllers is not that good, you know, so that's something to be borne in mind. But got to say, I mean, it looks really good. The brightness on this screen is not amazing. It's, you know, what I said at the beginning of this video. It's quite a tired monitor, but that looks great. I mean, honestly, that looks really, really good. So I would say if you're looking to get a flicker fixer to use with one of these cards, then the adapter that I've used is doing a really good job. And so far, I haven't seen any issues with it. So I would say definitely this gets a thumbs up and is definitely an option if you need a flicker fixer to work with one of these RTG cards. So before we finish off, there is one more thing I'd like to show you, and it's a very quick demonstration of a piece of software that comes with RTG cards, and it may inform you on some of the sort of funny artifacts that you've been seeing during this video. So let's do that next. Okay, let's get into the machine. So what I'm going to show you is a piece of software that comes as part of the Picasso 96 suite of drivers. I don't actually have the commercial drivers. I've been told that the actual commercial ones are better, so I am thinking about investing in those. But even in the free ones, you have this piece of software, and I'll give you a quick demo of what it does. It's interesting because it's a little bit esoteric. but it does make a big difference to the use of the card. So it's this, and what it does is it allows you to configure the different display modes that the hardware is capable of. So the first thing you need to do at the top is to assign it to a board. So I'm going to assign it to this board. It's telling me that all of these display modes are not actually viable, I think, on this particular monitor. I'm going to say OK to all. In other words, just ignore that. And what I want to do is, for instance, go to 800 by 600 up here. So you can actually tweak the clock speed here. So you can see it's currently set to 21 megahertz. Now, out of the blocks, this was actually set to 30, I think it was 31 megahertz here. There we are. So basically, I'm adjusting it down here so I get the frequency here, the horizontal frequency to 31 kilohertz, which is basically VGA. And if I was to test that, let's test that now. Here we go. So with the settings that it came with originally, this test pattern isn't working quite as well as it should do. You should actually see all of the test pattern on screen at once. Ideally, sometimes you don't really need all of it because the menu basically the image can be inset slightly. But I found that when I was using this mode, 8-bit color, 256 colors, which is quite a good mode actually, it's fast. It was slightly off screen, as you can see here. What's nice about this piece of software is it is a little bit weird to use, but when you're testing, it does actually wait for you to click the mouse button to cancel. That's quite nice. So let's go back to the UI. So let's now change it. And what I want to get is down here. So this is 21 kilohertz. There we are. And then let's test that. And yeah, basically I fiddle around and I tried 21 kilohertz and I found that that is great. As you can see, everything fits on screen. None of these lines are kind of ghosting. Sometimes you will find that you get a kind of ghosting effect. So what happens is certain pixels align, I think, with the pixels in the monitor, because this monitor has hard-coded pixels, as it were. It's not like a CRT where you have basically a scan line that can kind of represent pixels. And the pixels seem to go out of phase with the actual monitor and you get a poor display. So if we were happy with that, what we could do now is we could click on Save, and then it will tell you to reboot your machine to apply that profile. And the next time you use that resolution, when you're working in the preference panel, you will actually see the results of what I just did there. Now, the fruits of that is that this mode here, actually, let's just say no, I don't want to save that. Yeah, actually, let's accept these changes, yes. So yeah, I've gone to 1024 by 768 and 256 colors there. And none of these resolutions, 1024, were working previously. So I tweaked around with this a little bit. And I think it's this one in particular. So if you have a look at all of these, they're all 74 hertz, and this one is 37. So I believe this is the one that I tweaked, 256 colors. So I obviously have a task ahead of me where I need to probably go through all of these and tweak them for this particular setup here. So if we test this, so it's making some adjustments, and there we go. Bang on screen, everything perfectly sharp, everything looks amazing. So let's just click on that. And we'll say save, and it'll say, do you want to reboot? Yes, I do. And in a second, it'll give me the button so I can reboot. Well, let's let it reboot. What I'm going to do now is I'm going to change the resolution to that particular resolution that I just adjusted. And now I do actually have 1024 by 768. And I would say that it is my new preferred resolution. Previously, I was going with 800 by 600 because basically it worked. And now I have that resolution to work with. So yeah, I obviously will have to spend some time going through these resolutions and trying to get them all tweaked so that they work correctly. So let's go up here. There we are, 1024, 768, 8-bit. And over here, it says it's running at 37 hertz. So let's use that. Fingers crossed it should work. And there we go. And it looks really, really good. Yeah, really, really fantastic. Well, that was, I hope you agree, a pretty action-packed video. Obviously a pretty narrow subject, trying to get the pass-through cable working on my Piccolo SD64. However, for anybody else out there who's thinking about getting one of these cards or a similar card, there are a number of other cards which are available from this era. That's why we have the term RTG, because it was a family of cards from different manufacturers. Then hopefully you've got a much better idea now of all the different solutions. In the last video, I didn't really quite comprehend that, I needed to have a flicker fixer or a multi-sync monitor. Well, I know that now, and it's pretty clear how that works. I hope you enjoyed the explanation about the whole, the genesis of the Amiga and then television technology. I thought it was a good idea to just kind of have a quick exploration of that because, you may start saying to yourself, well, why 15 kilohertz? Why didn't they just go for VGA? Now, hopefully it makes sense why they made those decisions back in the day. Very often people are critical as time moves on and they go, oh, well, they made these bad decisions. And that isn't really the truth. The reality is that there were certain design considerations that are usually put in front of people, for instance, with J minor being told it had to be a console as well as being a computer. When you make that decision, you have to use television technology because you can't use a console on a monitor. It's just too expensive. It wouldn't be mass market. And that is why the Amiga was designed from the ground up to have television technology as its display methodology. Now, obviously, later on, that caused problems because, it's a very capable computer and people wanted to use it for productivity, and they couldn't really do that very well only using television modes because obviously when you get to higher resolutions, you get flicker, and hence we get into the whole RTG era. What I thought was really interesting is that we can obviously use the 15 kilohertz modes using one of these multi-sync monitors. I obviously need to get this one repaired, ideally repaired if I can, by buying a new panel, if that's possible. And then obviously the other one, which I've tucked away under a desk over there, I can get that working as well. It's a great monitor. It's just that the panel has had its life basically, and I've bought it after that life. It hasn't actually ended, but it's getting towards its end. And during this video, you may have seen my hand going grey when it was moving in front of the screen, and that's because I was actually color correcting the screen to get rid of the very strong sort of pinky tinge that you can see on camera. That's more to do with the color temperature of the camera. In person, you don't really see it being that pink. It actually looks quite grey, to be honest. So anyway, there was the second technology that we looked at, which is using a flicker fixer card. This would have been the one of the standard cards that they would. Well, this wouldn't be, but this is a modern card. But it basically does flicker fixing as the old school cards did. There was a card that came out from Commodore, and this card works really well. However, you do see some artifacts in it, some jail bars, and so that was a little bit of an issue, but for certain people, this may be the perfect solution for what they're looking at. Yeah, it's a little bit disappointing. I spent quite a bit of money on this, and I had to wait for this to turn up before I started on this video. But there we go. The only reason why it looks a little bit deficient is because of the card that's already in this machine, and that is the RGB to HDMI. And I found that with that, when I used that relatively inexpensive HDMI to VGA converter from Amazon, surprisingly good results. As I said, the pixels look a little bit softer than with the flicker fixer card. However, as I said in the past, that would have been kind of similar to what you would have seen on a monitor from back in the day, something like a 1084S or something like that, which was a very common monitor to use with both Commodore 64s and Amigas, basically a sort of television monitor that would run at 15 kilohertz. So, you have that option, or you can stick with the flicker fixer and accept that you may see some jail bars, but then you may get sharper pixels. So if that's what you want, go with the flicker fixer. I think the flicker fixer cost me, I think it was something like £118, and I think you can get an RGB to HDMI for about £70, £60, something like that, depending on which model you get. Some have more buttons, which I think are the ones which are worth going for. Funnily enough, I've actually seen one selling for 70, and that's actually the one with one button, which I think is maybe not as good. But anyway, there we are. When you start off on a journey, sometimes you don't know exactly where you're going to end up. And I'm just happy that I've managed to eventually scratch that itch from 33 years ago. In the last video, we kind of partially scratched it, but towards the end of the video, I made the cable and I just couldn't get it working. And there was definitely unfinished business which had to be continued on. So yeah, there we are. We've got it working. Pass-through's working. Let me just kick off actually Frontier just to show it working. And yeah, what I'd like to ask you to do is to please subscribe if you haven't been here before, because obviously if you really enjoyed this video and you want to see more from me, then subscribing is a really big help to the channel. If you're going to do that, then please click on the bell as well, because that then means you get notified about any videos that I produce in the future. And if you did enjoy yourself, please click on like as well, because obviously that will help the video go out to more people out there on YouTube. If you don't like the video or hype it, if you're able to hype the video, that's also very much appreciated. If you don't do those things, then the video won't necessarily be seen by all the people that would potentially like to see it. So anyway, thank you for coming and watching, and hopefully I'll see you in my next video, which will be coming out pretty soon. But until then, take care and goodbye.